Hello, students. Today we're going to review factoring, and this will be our first day of review. I will pause the video at certain points so that we can work on problems as a class. Okay, number 1. Always factor out the GCF first. Check for special case polynomials. For example, you may have a difference of squares, which would be a squared minus b squared, and that would factor to a minus b, a plus b. This should be review. Perfect square trinomials, a squared plus 2ab plus b squared. Usually I check to see if the first term is squared and the last term is squared. And if I could take the square roots of both of those numbers, then I see if the middle term adds up to twice their square roots. You'll see examples in this. So that gives us a plus b, and then it's squared. If we are still stuck and we can't do either of those, or we've already done those and we want to see if we can factor further, we can factor by grouping, and we can factor by trial and error, and then there's a method that I like to show called the cross method, I think, and I'll show you that while we're going over these examples. Okay? Let's do A together with me and C with me, and then we'll pause the video and do B and D as a class. Okay. So the first thing I'm going to look for is a GCF. And it looks like we can divide out of 5, an A, and a B squared. When I do that, I divide the first term, 10 by 5, that gives me 2. I divide the A's, those A's cancel. I divide the B's, and that leaves us with just B to the first. Minus 15 divided by 5 is 3. A squared divided by A is A. B squared divided by B squared is 1, so we don't need to write it. And that looks as far as we can factor. C looks like a difference of squares. There's no GCF, but there's a difference of squares because the square root, I'll write that here, difference of squares. The square root of 4 is 2. The square root of s squared is s. The square root of 9 is 3. So I write 2s minus 3, and I write 2s plus 3. If you distribute that out, you will see that you get 4s squared minus 9. Okay, let's pause the video and do B and D as a class. All right. Same thing, we'll do E, G, and I with me, and we'll do F, H, and J as a class. Okay, for E, I want to factor out the greatest common factor, which is 3. And then I get c squared, 75 divided by 3 is 25. And I notice that that is a difference of squares. So we first started with the GCF, and then we did difference of squares. So the square root of c is c, the square root of 25 is 5, and then I write c plus 5. Bring down your GCF of 3. Okay, for G, I don't see a greatest common factor, and it doesn't look like a perfect square trinomial, so I'm going to use the box method or the X method. And I am looking for factors of C, so factors of negative 10 that add up to 3. So I put negative 10 up here, saying I want two numbers that multiply to give me 10 and add up to give me 3. So that would be 5 times 2 is 10. And if I make the 2 negative, when I add negative 2 plus 5, I get 3. So they multiply to give me negative 10, and they add to give me 3. So my factors are x minus 2 and x plus 5. If you distribute that out, you get x squared plus 3x minus 10. For I, we're going to factor out 2, because we can divide everything by 2 and an x squared. 2 divided by 2 is 1. X to the 4th divided by x to the 2nd is x to the 2nd. Negative 4 divided by 2 is negative 2. X to the 3rd divided by x to the 2nd is x. 8 divided by 2 is 4. X squared divided by x squared is 1. And 4 times 1 is just 4. And I'm looking, I factored out a GCF. I'm trying to think if there is any numbers that would multiply to give me 4. And the only thing I can think of is negative 1 and 4, or negative 1, negative 4. But those added together would be negative 5. And negative 2 times negative 2 is negative 4. Is positive 4, but those add up to be negative 4, not negative 2. So that's as far as we can factor that. Let's pause and then do F, H, and J. Okay, let's do K and M. Ooh, this one's tricky. Okay. I could factor this by grouping, but instead I'm noticing that I can take the square root of both of those, which would give me a 2 and 7, right? 2x and 7. And 2 times 7 is 14. If I double that, I get 28, which is the middle, right? So this is in the form why did it do that? A squared plus, well, in this case it's minus, but it'll still work. AB plus B squared. All right. To make it a negative, what I'm going to do is make the 49 a negative 7 times negative 7. And then this will be 2x times 2x, right? So my factors are going to be 2x minus 7 and 2x minus 7, so it's just 2x minus 7 squared. And if you expand that and you distribute, you end up getting 4x squared minus 28x plus 49. Okay. For M, it is 4 terms, but first we're going to factor out a GCF because each one of these is divisible by 3, and also an M. 45 divided by 3 is 15, so we'll get m to the 3rd. Minus 9 divided by 3 is 3, m to the 2nd. 30 divided by 3 is 10, m. 6 divided by 3 is 2. Now I'm going to factor by grouping. And I like to show factor by grouping like this. So I'm going to group these two together, and I'm going to group these two together. And in the end, we have to remember to bring down our greatest common factor. So for the first grouping, I have a greatest common factor of 3m squared. When I divide that by each of those terms by 3m squared, I get 5m. 3 divided by 3 is 1. M squared divided by m squared is 1. I have to put the 1 because that's all we have. Plus 10 and 2. So I can divide those both by 2. So I get 2 on the outside. 10 divided by 2 is 5. M minus 2 divided by 2 is 1. Now what you notice is these two term or expressions are the same, and they're going to go together in a pair of parentheses. And then this 3m squared and this plus 2 occupy the other parentheses of our factors. And then we bring down our GCF. So what we did here was we did GCF and grouping. And I should say above that this was a perfect square trinomial. No, it wasn't. I'm sorry. Oops, erase, erase. That was not a perfect square trinomial. See, I already forgot what we did. That was a difference of squares. And writing them on the side is helpful so that you know what type of problems we're doing. Okay, let's pause the video and do L and N together as a class. Okay, let's take a look at O. Oh, I think we're going to have to maybe use some grouping for this. What I like to do is take the A and C and multiply them. That gives me 12. And figure out if I can get something that would add up to 7. Maybe we don't have to do grouping. Let's see. So what are factors of 12 that add up to 7? Well, 3 times 4 is 12, and 3 plus 4 is 7. So that's what I'm going to use. No, I have to factor. And so it's going to be, they add up to 7x, they multiply to 7 or 12x squared. So each of these, the 3 and the 4, are going to come up and make the 7 split into those. I'm going to write it down so it makes more sense. 6x squared. The 7x becomes 3x plus 4x. And then we have the plus 2. And I forgot this plus here. Now I'm going to group them. And from there, we can factor out a 3x. 6x squared divided by 3x, so 6 divided by 3 is 2, so 2x. 3x divided by x is 1. 4x plus 2, we're going to factor out a 2, and that'll give us 2x plus 1 as well. Cool, these are the same. That's what we're looking for when we're doing the grouping. So the 3x and the 2 go in a pair of parentheses, and then the parentheses that were the same go in one set of parentheses. All right, so we had to multiply A and C, figure out what factors of that would add up to 7. Then we had to do grouping. Okay. Kind of like makes less sense now that it's all written everywhere. But that's where the 3 and the 4x came from, because they add up to become 7x. Let's look at Q. I don't think Q is factorable, because if I multiply 4 and 6, I get 24. And I can't think of anything that would multiply to give me 24 that would add up to -9. Because both factors would have to be negative for that to work. So this is not factorable. If I'm wrong, let me know. But let's pause the video and do P and R. The zero product property helps us solve quadratics. So what it's saying is if I multiply two numbers, A and B, and my answer is 0, my product is 0, then either one of them has to be 0 or they both have to be 0, right? If I multiply 3 numbers together, then one of them has to be 0 or any combination of them has to be 0. And then they write it with A, B, and C. So when it asks us to solve, we have to use the zero product property. But first, I want to set this quadratic equal to 0 so that we can solve it. All right, this looks like one of those factors of A dot C equal to B. Let's do a cross like that, and we're going to multiply these two. So 2 times negative 12 is negative 24, right? Then I want them to add up to B, which is 5. What multiplies to give us negative 24? That would add up to 5. Well, I'm thinking 8 and 3 because the difference of those is 5. Okay, so then the 8 and 3 is what is going to become of the 5x. So we'll have, instead of 5x, we're going to have 8x minus 3x. See how those equal the 5x? Then I'm going to bring down the 2x squared, and I'm going to bring down the minus 12. So this x method is the trial and error method. Now I'm going to group these. And you can always rewatch these videos if you're struggling to remember, how do I do that again? Especially when you're doing your homework tonight. Okay, so I'm going to factor out a 2x, and that becomes x, and then 8 divided by 2 is 4, and x divided by x is just 1, so I don't have to write that. Then I'm going to factor out a negative 3, and that will leave me with negative 3 divided by negative 3 is 1, and that leaves us with just x. Negative 12 divided by negative 3 is plus 4. That's great because these are the same, and so we get 2x minus 3 goes in the first set of parentheses, x plus 4 goes in the other set of parentheses. And that is our answer. We're going to box it. And then we'll do B together, and we'll be finished with our guided notes.